Hello, folks. Welcome back. This is part four, learning Rust from scratch. So we were actually, importing the RAND crate, library crate, and so now we are actually looking at how the cargo build looks like. So cargo build doesn't change much, but I do have the old output. Thankfully, I didn't, scratch it off. So basically, you can see that it is it's getting 0.8.5 only, and so you may see different version numbers. In this case, 0.8.5 is showing, but yeah, you may see different version numbers, but they'll also be compatible with the code thanks to some semantic versioning and different lines depending on the operating system, and the lines may be in a different order. So, for example, I don't have Unicode indent or proc macro to or PPP like 86. Oh, I do have PPP like 86, but zero copy, yes, I do have that, but I don't have zero copy there, right? Run Chacha is there, and Run is there. Yeah, okay, great. So there is no code, is it? There's no code and whatnot. But there is CFG and libc and all that, right? Okay, so in this case, when we include an external dependency, cargo fetches the latest version of everything that dependency needs. So this brand dependency in this case needs from the registry, which is a copy of data from crates.io. So crates.io is where people in the Rust ecosystem post their source code, like open source Rust projects, for others to use. After updating the registry, cargo checks dependencies section and downloads any crates listed that aren't already downloaded. And in this case, although we only listed RAND as a dependency, Cargo also grabbed other crates that RAND depends on to work. After downloading the crates, Rust compiles them and then compiles the project with the dependencies available. If you immediately run Cargo build again without making any changes, you won't get any output aside from the finished line. Cargo knows it has already downloaded and compiled the dependencies, and you haven't changed anything about them in your cargo.toml file. Cargo also knows that you haven't changed anything about your code, so it doesn't recompile that either. So with nothing to do, it simply exits. If you open the source main rs file, make a trivial change and then save it and build again, you'll only see two lines of output, which is compiling, guessing game, and finish. These lines show that Cargo only updates the build with your tiny change, to the source main.rs. Your dependencies haven't changed, so Cargo knows it can reuse what it has already downloaded and compiled for us. So, ensuring reproducible builds with the cargo.log file. Cargo has a mechanism that ensures you can rebuild the same artifact every time you or anyone else builds their code. Cargo will use only the versions of the dependencies you specified until you indicate otherwise. For example, you say that next week version 0.8.6 of RAND crate comes out, and that version contains an important bug fix, but it also contains a regression that will break your code. To handle this, Rust creates the cargo.log file the first time you run cargo build. So now we have this in the guessing game directory. When you build a project for the first time, cargo figures out all the versions of the dependencies that fit the criteria and then writes to the cargo log, right? So when you build your project in the future, cargo will see that the cargo.log file exists and will use the version specified there rather than doing all the work of figuring out the versions again. This lets you have a reproducible build, that is, that you can keep reproducing and producing again and again automatically. So, in other words, your project will remain at 8.5, 0.8.5 until you explicitly upgrade thanks to the cargo.log file. Because the cargo.log file is important for reproducible builds. It's often checked into source control, that is Git in this case, in our case, with the rest of the code in your project. Updating a crate to get a new version. So when you do want to update a crate, Cargo provides the command update, which will ignore the cargo.log file and figure out all the latest versions that fit your specifications in the cargo.toml file. So latest versions there figures out the latest versions that fit your specifications in your cargo.toml file. Cargo will then write those versions to the cargo.log file In this case, cargo will only look for versions greater than 0.8.5 and less than 0.9.0. If the run crate has released the two new versions 0.8.6 and 0.9.0, you would see the following if you run cargo update. Cargo ignores 0.9.0 release. At this point, you would also notice a change in cargo.log file, noting that the version of RAN crate you're now using a 0.8.6. To use RAN version 0.9.0 or any version in the 0.9.x series, you would have to update the cargo.toml file to look like this instead, 0.9.0. The next time you run cargo will update the registry of crates available and reevaluate your RAN requirements according to the new version you have specified. There's a lot more to say about cargo and its ecosystem, so publishing and all that. So, which we'll discuss in chapter 14. But for now, that's all you need to know. Cargo makes it very easy to reuse libraries, so Rustaceans are able to write smaller projects that are assembled from a number of packages, right? So, in our case, I think the rand crate crates.io. Can you just say rand and will it? Cool. So here, if you look at the versions, you have 0.9.0, beta 0.8.5 is the last. After 0.8.5, there's no 0.8.6, 0.9.0, and 0.9.1. So, cool. So now we have ensuring reproducing builds with Hyperrun log file. We haven't done that. We've seen that. Now, let's start using RAND to generate a number to guess, right? The next step is to update source main.rs as shown in listing 2.3. So, we are going to get the secret number out here. So before we say guess the number, we are also printing it just like that. First, we add the line this, the range. Okay. So we add this. So we add this, and then we say okay, secret number. Guess just below the guess the number. So secret number. So secret number, thread range, gen range, 1 and 100. I think this includes 100. Right, so this is a range and R. So think range of sample. Okay. Okay, what is this R? R is basically sample range, as you can see here. And okay, so range that supports generating a single sample efficiently. And limiting this rate can be used. It's a trait, kind of like an interface, I think. So it has sample single and only empty. So okay, and let's go here. This is another trait for the RAM thing, and cool. So there are different ways to generate, you know, numbers. So here it's an inclusive range apparently. So it is including 10, I think, but I'm not sure if it includes 0 also. Let's read about that. Before that, I'm just going to actually run the program, I think. Let me just do this. And let me do cargo check, cargo build. It's compiling, cargo build again, okay. Cargo run. So, yep, we can see the secret number. I will continue in the next video. So that's all I have for this one. I'll see you next one. Bye.